With the rapid development of the domestic economy, China is now in an unprecedented period of large-scale infrastructure construction. Cost of million and billions as super projects have been launched. It has demolished some old projects. But when it comes to buildings of great significance, but it made it difficult for the engineers. No new project can be built without demolition. If you tear it down, you will lose the inheritance of Chinese culture. In addition, some modern projects also play a very important role. The builders chose to move the buildings. That's the building translation technology. On April 4th, China carried out a translation project for the largest single building in China. Turn the 36,000-ton train station 90 degrees. The station has 2 floors below ground. If you cut the ground in the traditional way, this can cause the building to become unstable during translation. It can also damage the interior of the building. For this, the builders moved the basement together. 532 walkers were set at the bottom of the station. Slide the station around. Although this station translation set a world record, but at least it is a modern building much stronger. In addition, there are 96 supporting columns inside the station. If it's a nearly century-old building, how do we shift it? The Great Hall of Shanghai gives us the answer. This is a building built during the Guangxi period. So far has been in the high-rise city through over 130 spring and autumn. According to statistics, the main hall of the annual passenger flow can reach 2 million. The square space in front of the hall is extremely crowded. Add jaws stick more flourishing. These can cause major passenger flow safety hidden trouble. Shanghai officially launched the Fire Safety Hidden Danger Protective Repair Project. With the help of modern translation technology, the main hall of the north displacement of 30.66 meters. It will also lift 1.05 meters when in place. In addition, the internal Buddha statue and cultural relics should follow the construction to complete the translation. This has no precedent in the history of domestic architecture. The main hall is a wooden structure supported by wooden columns. Compared with reinforced concrete buildings, the translation difficulty is greatly enhanced. And this palace has been going through nearly 100 years. Hall tile and wood structure are worm-eaten or loose. There is no guarantee that it will move to a distance of 30 meters. Before the translation, the construction team made a comprehensive inspection and marking off the main hall. And to the inside of the temple support column survey, merge the loose place. And then it's ready to shift. First, several underground wooden columns were united into a hole. Place the tray under the wooden post, so that the main hall is completely located on the permanent steel structure tray. In addition, 90 pile holes are reserved for the tray. Use the building's gravity to press into the steel pipe pile. The 90 steel poles will eventually be attached to the tray. The second step is to excavate the slide beam. The slide beam construction is completed. The entire hall will be firmly supported on 90 steel tubes. Then pave the slide path. 46 vertical jacks shall be installed between the slideway and the upper tray. After 3 months of preparation, the palace translation work officially opened. 46 jacks were lifted alternately, and the translation length on the first day was 2 meters. It then moves at a rate of 6 meters per day. At the same time, jack is lifted 30 centimeters high every day. After 7 days and 2 nights of continuous fighting, the main hall shifts smoothly to the designated position. Project Chief Engineer said, in order to ensure the safety of the hall translation, the acceleration and speed of displacement are strictly controlled by the construction workers. Sensors are placed on buildings and Buddhist statues. It is used to monitor force and deformation in real time. These observation points include electronic information sensors for force and deformation, optical observation of surface changes, and other ways to monitor the whole process of displacement in real time. For example, 7 static levels were set during the construction process, used to detect the settlement of Buddha statues. More than 10 tilt sensors are used to monitor the tilt of the wooden column. The laser rangefinder detects the displacement of the Buddha statue, and so on. This data will be collected in real time and transferred to the computer terminal. If there is any deviation, the engineer will adjust it on site. Finally, the translation accuracy and safety of the hall are guaranteed. Chinese building overall translation technology started in the 1980s, almost half a century later than in the West. But the speed of development and translation technology is very fast. According to statistics, more than 30 buildings have been translated abroad so far. China has 136, 4 times more than the rest of the world combined. Therefore, China's building translation technology ranks the world's leading level. In the future, the speed of modern urban construction will speed up. Architectural translation will also bring greater social and economic significance to China. And the effort that realizes all these cannot leave Chinese engineer.